This is Lesson 2, Part B, the second part in Algebra 2. We're still on page number 28, middle of the page, and we're going into another section called Power Theorem for Exponents. And what we had done before is we said something like x cubed times x squared is the same as x to the 3 plus 2, which equals x to the 5th. Well, in this one, when we're talking power theorem, we're going to take x cubed and we're going to put it in parentheses and square that. When that happens, when these two numbers are like that, that's the same as x to the 3 times 2, which is x to the 6th. So one of the other things we're going to do is we're going to extend that power theorem so that if we have x squared y to the 4th and we cube that, that equals x to the 2 times 3, which is these two, y to the 4 times 3, these two. So that 3 goes on both the x and the y, giving us x to the 6th, y to the 12th. Alright, so that brings us up to some examples, like on the bottom of page 28. In that first example, looks like that, and they want us to simplify. So we're going to use the power rule, and so we're going to look at this part here first, and we're going to rewrite that as x, because this 2 here is not on that first x, but we're also going to take negative 3 times 2 here and get negative 6. Then we're going to put the y, and then we're going to use the power rule for this. So that'll be x to the negative 3, because this is an assumed 1, so 1 times negative 3 is negative 3, and y is going to be negative 2 times negative 3, which is a positive 6. Now we're going to go on the bottom and do the same thing, and we're going to get y to the 2 times 3, y to the negative 3, because there's nothing being done there, and our x squared cubed is going to be 2 times 3 is 6. Now let's start combining. So we've got an x to the 1, which is right there, minus 6, which is right there, minus 3, which is right there. Then we've got y to the 1, which is there, plus 6, which is there. And we're done with the numerator. At least we'll combine those exponents in a minute. Our bottom, we have y to the 6th, and we have a negative 3. So we're going to minus a 3, and then our x to the 6th, this one there, will stay like that. So now this looks like x, very top, 1 minus 6 is negative 5, minus 3 is negative 8. And y is going to be y to the 7th. And down on the bottom, y to the 6 minus 3 is 3, x to the 6th. Okay, so we can leave it there, but usually what they want to do is they want you to have positive exponents. So let's take this and go clear over here, up there where I have some space, and put these in the right place. Well, the x to the minus 8th is in the numerator position, but it's telling us it's in the wrong place. So let's put it in the right place so that it can become positive. Our y is already positive 7, so we know it's in the right place. Our denominator, y, is a positive, so it's in the right place, and our x is a positive, so it's in the right place. So when we switch everything, we get that, but what do we see here? We've got an x here and an x here, so we can combine those. So y to the 7th over y cubed, that didn't change, but we're going to add the 8 and the 6 together and get 14. Now one of the things I notice is I have a y and a y, one in the numerator and one in the denominator. Well, what if I took this y cubed and moved it to the wrong place and moved it up, put a negative sign on it, left my x to the 14th down here? Now I could get x to the 7 minus 3, or I'm sorry, I can get y to the 7 minus 3 is 4, and then I've got that over x to the 14th. And that even makes it simpler than what I had when I had my answer up here. So you can move things around. You just have to remember when you move things, you have to switch the positives and negatives, because if you're putting it in the wrong place, you have to put the negative sign on it. So that is the power theorems. This next section has to do with circle relationships, and this is top of page 29. So if we know the area of a circle, we can also find the diameter of the circle, and we can find the radius. If we know the circumference, we can also find the diameter and the radius. So for example, if we have the area of a circle, and we say that that is 12.2, well, I know the area of a circle, the formula is pi r squared. So 12.2 equals pi r squared, because these are the same. So if those are the same, these have to be the same. Okay? Well, if I took 12.2 and I changed pi to 3.14 and left the rest the same, and I wanted to find r, I divide both sides by 3.14. Those cancel. So this then equals r squared. So 3.89, which is what this divides to, is equal to r squared. And if you remember in Algebra 1, if you're trying to get rid of an exponent here, you take the square root of both sides. So the square root of 3.89 is 1.97-ish, and that is a number close to the radius. So we found the radius based on the area. If I double that, then I've got the diameter, and I can also go from all of that to the circumference, which is 2 pi r. Well, I found r is 1.97, so I could find the circumference by doing this and finding the circumference. So I can go all over the place just given a little part of a circle and just kind of using the formulas, and makes it easy for me to go ahead and find the other part. So let's say that the circumference of a circle is 8 pi, and I am interested in finding the area. Well, the area of a circle is pi r squared. Alright, so that doesn't really help me a whole lot, does it? But I do know that the circumference of a circle is 2 pi r. Well, if 2 pi r is the circumference, and 8 pi is also the circumference, then 2 pi r is the formula I used in order to find my circumference that was given of 8 pi. Now notice, whenever I've got numbers multiplied, like I have 2 and a pi and an r multiplied here, and an 8 and a pi multiplied here, I've got a pi here and a pi here, I can just cross out my pi's. And that gives me 2r equals 8, and r then equals 4. Well, now that I found out that r equals 4, I can take that and plug it in here. So my area of a circle is now pi times r squared, or 4 squared, or 16, and that ends up being my area. And I'm just going to leave that as 16 pi because that's an exact answer. If you have 16 times 3.14, you're just putting an estimate in there. So that's problem set number 2, the second video, and that is it for lesson number 2.